Hello friends, welcome back to another lesson with me Arun Sharma on Coding Ninjas, and we are looking at in today's lesson. In this lesson we are looking at ratios, a new chapter actually. Ratio, proportion and variation is the chapter we are heading to now. And just like percentages, this is again a big chapter for arithmetic because of the fact that ratio, proportion and variations is the base chapter for your next two chapters, which are time and work and time, speed, distance. Just like percentage was the base chapter for profit and loss and interest, ratio, proportion, variation is the base chapter for time and work and time, speed, distance. And hence understanding ratio, proportion is important. Not just because of its own questions, but also the application of this across those chapters I mentioned. So we will start off by first discussing in today's in this lesson, the first lesson of this chapter. We're going to discuss a very simple aspect about what ratios are. We're going to look at the theoretical aspect of ratios. So ratio, as you would well know, is essentially a comparison. It's a method to compare quantities. Ratio is a method to compare quantities. Right? And two quantities or two or more quantities you want to compare. And naturally, when you talk about comparison of quantities, the first thing that comes to mind is that, or the first thing one should realize, is that the quantities should be, the quantities you are comparing should be in the same units. You can't compare, after all, a 20 kilometers per hour with a 80 rupees per kg. These two numbers can't be compared. So first thing that happens is that when you are comparing quantities, you are always comparing quantities between two quantities using the same unit. So just like you can't compare a 20 kilometers per hour and 80 rupees a kg, you can't even compare a 20 kilometers per hour with an 80 meters per second, because the comparison doesn't work here, even though both are speeds. You can only compare two things if their units are same. And hence, when you compare, let's say 20 kilometers per hour with 80 kilometers per hour, and you take a ratio between them, a ratio is nothing but the division of one by the other. So if you take a ratio between them, with this being the numerator and that being the denominator, so you get a ratio of 20 by 80 or 1 by 4 for the two speeds, and this ratio in ratio terms is also written as 1:4. So the first principle of a ratio is that it's always a unitless quantity. A ratio is always a unitless quantity because when you divide a number in some units by another number having the same units, the units will cancel out, and hence ratios are always unitless. Right? Using the logic of dimensional analysis of variables, you can understand that whether it's kilometers per hour divided by kilometers per hour, it's meters per second divided by meters per second, or rupees per kg divided by rupees per kg, or for that matter any other unit whose ratios you might want to compare, the ratio becomes unitless. Now there are a few aspects to ratios, or a few important properties of ratios that you should know. That if you have a ratio A by B and you multiply both the numerator and denominator by the same number, the ratio does not change. MA by MB is the same as the original ratio. The ratio remains unchanged. So for example, if I have a ratio of C by 4 and I multiply this by 6 and I multiply that also by 6, I'll get a ratio of 18 by 24, which is equal to 3 by 4. Of course, in that context, you should also know one more thing here, that the 3 by 4 is referred to as the lowest form of the ratio, because a 3 by 4 can be multiplied by a 2 to give me a 6 by 8, and it can be multiplied by a 1.5 also to get me a 4.5 by 6, or it could be multiplied by 3 to get me by 9 by 12, or you could multiply this by 4, 12 by 16, and so on, or you could multiply it by 1000 to get 3000 upon 4000, or you could multiply it by any number m to get an MA by MB. So there are infinite values, infinite ratios that have the same basic value that this least form or the lowest form of the ratio has. And the point where the situation where the lowest form of the ratio gets created, the situation or the value at which the lowest form of the ratio gets created will have one particular property, that is, the number in the numerator and the number in the denominator should become co-prime. Unless the numbers are co-prime, numerator denominator numbers, if they are not co-prime, then you will further be able to break down the ratio or bring it down to a further lower form. But once the numbers become co-prime, the ratio will not be reducible further. So if you have a ratio, for example 10 by 14, this is not the lowest form of the ratio, because you can see that 10 and 14 are not co-prime to each other. Remember what co-prime numbers were? Co-prime numbers were numbers which had the HCF of two numbers which had the HCF of 1. So if you divide both by 2, the ratio becomes 5 by 7, and this value is the original ratio or the lowest form of the ratio 10 by 14, right? So just like I can multiply a ratio by the same value m, I can also divide to have the same ratio. I can also divide a ratio by the same divisor, both the numerator and denominator. As I divide the numerator and denominator by the same divisor, my ratio would be same. So if I have a 10 or a by b, and I divide this by d and I divide that by d, I get a ratio of a by d upon b by d, and this value will be the same as a by b as a ratio, as you could see in this case, right? So this is the starting basics of ratios. And one more thing maybe I will talk about here, and that is that if you are dividing a ratio by another. So right now we have talked about multiplying a ratio by the numerator and denominator of a ratio by a constant, and then we also talked about dividing the numerator and denominator of a ratio by a constant. The ratio's value does not change. What is the structure of dividing a ratio by another? If you're dividing a by b by c by d, what happens? So what happens, and this can also be written as a by b is to c by d. This can be written as a by b is to c by d, and this converts to ad by bc. This is something that you should know and you should be able to do, because this happens often in maths quant situations. So for example, to give you an example of this, let's say, and the way this happens, before I give you the example, the way this happens is that a by b upon c by d can be written as a by b into d by c, and that's how it becomes ad upon bc. Now likewise, if you multiply two ratios, you can have a parallel example for that, or a parallel structure for that. But first of all, let's take a couple of cases for this situation. let's say you have a ratio of 2 by 5 which is divided by 5 by 8. So as we saw, this ratio will invert and become the multiplier of the numerator ratio, 2 by 5 into 8 by 5. So this ratio divided by ratio would give me a solution or an answer of 16 by 25. And instead of that, if I face a situation of 2 divided by 5 divided by 5, for example, I should be able to visualize this. And if my denominator is not a ratio but actually an integer, the final divisor is an integer, I should be able to visualize this as 2 by 5 upon 5 by 1. And then the same logic applies. This becomes 2 by 5 into 1 by 5. So this becomes 2 by 25. So you should not get perplexed if you have this kind of a situation. So in general form, if a by b is divided by c, to this value converts to a by b into 1 by c. So it converts to a by bc, because what you visualize here is that this number is actually c by 1. So using the same principle as we saw earlier, you can get this done, right? And the next property is that if you multiply a ratio a by b with c by d, you get a value of AC upon BD. Right? You simply multiply the numerators and you multiply the denominators and you get the answer. So this is the basic structures or the basic understanding of the starting part of this ratio. There is some more applied theory which we will come to before we come to problem solving ratios. So in the next lesson we will talk about some more properties and look at a few more thought processes around the ratios chapter, which you need to build before you can hit the problems. So I'll wind up now. See you soon in the next lesson. Bye bye.